Hi everybody, Mr. Garrett here, and we're going to go over some new types of rational functions, a little bit different than the ones in the last video that were transformations of that 1 over x. These are transformations of 1 over x too, but they're a little bit more difficult to see in terms of how they're going to change differently than those. The biggest thing that we're going to do is we're going to work with, as I said, a little bit more detailed or complex polynomials in the top and the bottom in the numerator and denominator, and therefore it's going to cause us to have to do a little bit extra work. The number one thing that I want you to do when you come across a rational expression like this is to factor the numerator and denominator. It's going to see and allow us to do two things. The first thing it's going to allow us to do is see if there's any zeros or factors that are both in the numerator and the denominator. If that's the case, then there's a hole at that x value. Secondly, it's going to allow us to see what the zeros are in the numerator and the denominator, because those are where our x-intercepts and our vertical asymptotes are going to come from. Just like before, we can't have 0 in the denominator, and so if we have 0 in the denominator, that's where a vertical asymptote occurs. If we have a 0 in the numerator, that's 0 divided by anything, that's going to give us 0, and that's where an x-intercept occurs. If we plug 0 in for x, that gives us our y-intercept. And really what's going to be nice about this is in the original function, I can see what the y-intercept is by seeing what the constant terms are. So here, this would have a y-intercept of 5 over 1, which is just 5. And that's pretty easy to see. Lastly, we're going to look for the horizontal asymptotes. And the horizontal asymptotes occur based off of the degrees of the numerator and the denominator. N is the degree of the numerator, as you can see up here, is x to the n, and m is the degree of the denominator, which you can see here is x to the m. Now, if it's bigger on the bottom, if the degree is bigger on the bottom, then y equals 0 is your horizontal asymptote. If the degrees are the same, then you're going to take the leading coefficient at the top divided by the leading coefficient at the bottom, and that will be your horizontal asymptote. And if it's bigger on top, then there is no horizontal asymptote, and we have what could be called a slant asymptote if it's one more, and we'll define that using synthetic division. Finally, we're going to look at the graph on our calculator to find the general shape and or any other points, along with helping us find the domain and range of the graph. So let's get into a couple examples. The first one here is r of x equals x squared minus 9. And as I said first in the last page, we want to factor the top, which is x plus 3 and x minus 3. And we want to factor the bottom, which is just x squared. We can't do anything else with that. Now, looking at both the top and the bottom, we don't have any factors in common, and therefore there are no holes. Okay? The x-intercepts are the factors or the zeros of the top, and so this factor will give me a 0 of negative 3. This factor will give me a 0 of positive 3. So I have two x-intercepts, one at negative 3, 0, and one at 3, 0. The y-intercept occurs when we plug in 0. And if I plug in 0, I get 0 minus 9 up top, but I get 0 on the bottom. And that doesn't happen, and so we can't divide by 0, and we know then that there are no y-intercepts. Likewise, we look at the bottom, the denominator, and we know that x equals 0 gives us 0 in the denominator, and that's our vertical asymptote. If I look at the degree of the top, it's 2. The degree of the bottom is also 2. And so to find the horizontal asymptote, I'm going to look at my leading coefficients, which are both 1. So my horizontal asymptote is going to be y equals 1 over 1, because that's the leading coefficient at the top, leading coefficient at the bottom, and that's going to be just y equals 1. On the graph, I'm going to draw in my horizontal asymptote. There's y equals 1. My vertical asymptote, x equals 0. And my x-intercepts, 3, 0, and negative 3, 0. Now for the rest of the graph, I'm going to come over here to the calculator, and I see that I've graphed it, and this is what my general shape looks like. If I wanted to get specific points, I could go Control T, and it would give me better points like 1, -8, and 2, -1.25, 3, 0, and 4, comma 4 point, or 0.4375. But I get the general idea of the graph, and I can just sketch those points in like so. We got -8 down here, so that creep up like that, and then like this here. Now, for the domain and range, well, if I look at x values that start with -infinity, I'm going to keep getting closer and closer to 0 until I don't get there because of the vertical asymptote. I'm going to skip over 0 then, and then go 0 to infinity. Range, likewise, I'm going to start way down here at -infinity. But this time there's nothing above our horizontal asymptote, which is 1. And so I'm going to say -infinity to 1, not including either one because we don't cross that y=1 line. If we look at the next one, I'm going to go ahead and factor the top, which is x minus 2. Factor the bottom, which is x times x minus 4. And my x-intercepts are zeros at the top, which is 2, 0. Y-intercept, well, I would get -2 on top, but I would get 0 on the bottom again, and so there's no y-intercepts. We also don't have any holes because there's no factors on the top and the bottom that cancel out. Our vertical asymptotes are at x=0 and x=4 because that's where the bottom would be 0. And our horizontal asymptote is at y=0. It's at y=0 because the degree of the bottom is 2, the degree of the top is 1, 2 is greater than 1, and therefore is y=0. So I'm going to sketch in my information that I have, and let's see, x=0, x=4. So there's my asymptotes. I also have an x-intercept at 2. And I go to the graph. And when I go to the graph, I see what the graph looks like here. This is the middle part between the two asymptotes. And it's decreasing from left to right. It's also decreasing out here. And it's actually decreasing over here. So this is a very decreasing function. But we can go ahead and plot in some of those points. Again, I would look and try and get better points using my table. But for our purposes right now, we'll just sketch in what the branches look like, and that'll allow us to find the domain and range. So there's my graph. My domain is going to start at -infinity, go to 0, oops, and then go from 0 to 4, because those are my two asymptotes, and then go from 4 to infinity. The range, if you look, here covers every y value that we have on the graph. We also go up here to 0, and we come down here to 0, but we actually have a point at 0, 2, 0, which is our x-intercept. So our range is -infinity to infinity, or all real numbers. Another example. So with this one, what we're going to do is we're going to factor the top, and we're going to get 3 times x minus 2. The bottom, we're going to factor, and that's going to give me x plus 4 and x minus 2. Now, you can see right away that there are a factor x minus 2 on the top and on the bottom. What that's going to do is that's going to cancel out, and it's going to leave us with the equation 3 over x plus 4. Now, even though it's a hole here because these points left, we know the x value of the hole is 2 because that's the 0 at the top and the 0 at the bottom. And so there actually is going to be a hole, an empty spot in that graph. Now, what the y value is, we don't know. We don't know that because we don't know where it's at because there is no value. So there's a hole at x=2. We'll kind of look at some of the other stuff there as we go through. Secondly, we can find the x-intercept, which would be the zeros of just the top, and we don't have any zeros of just the top, and so there are no x-intercepts. For y-intercepts, if I plug in 0, I get 0 minus 6, 0 plus 0 minus 8. And so our y-intercept is 0, and then 6 over 8, or negative 6 over 8, is 3/4. Vertical asymptotes are just the bottom, and so that's going to be x equals negative 4. And because the degree on the bottom is bigger than the degree on the top, we're going to say y equals 0 is our horizontal asymptote. So I'm going to go ahead and draw in y equals 0 as my horizontal asymptote. I'm going to draw in x equals negative 4 as my vertical asymptote. I'm going to draw in 0 and 3/4 as my y-intercept. And I'm going to go to the graph. When I go to the graph, you can see right here that this is just looking like 1 over x, except it's moved 4 units to the right. And that would make sense if I look at my simplified version. This right here would be like 3 times 1 over x plus 4. 4 units to the left, shifted this way. My graph's going to look like this here. If I look at my y values and I plug in 2 here, I'm going to get 3 over 6, which is 1/2. And that's where our hole would occur because that would be where the value is if there wasn't a hole there. Likewise over here, I'm going to have my branch going down there. This helps with the domain. The domain is negative infinity to negative 4. And then we think that it goes negative 4 all the way to infinity, but actually remember there's no value at 2. And then from 2 to infinity. The range goes from negative infinity. There's no values at our horizontal asymptote, which is 0. And then 0 to infinity. And that's our rational function. One last one. If I take out a 5 on top, I get 5 and then x squared plus 1. On the bottom, I'm going to get x plus 2 and x plus 2. So there are no holes. The x-intercept, well, there's no way I can get 0 on top. So again, there's no x-intercept. The y-intercept would be 0 and 0, 5 over 4. So we'd say y equals 5/4 or 0 5/4. Vertical asymptotes occur when x equals negative 2 because that's the denominator. Horizontal asymptote is going to be y equals 5 because my degrees are the same and 5 over 1 is 5. There are no holes. And so I can come in here and say vertical asymptote at x equals negative 2. Horizontal asymptote at y equals 5. And y-intercept at 1 1/4. Go to the next graph. And this one here looks a little crazy. If I go and zoom out a little bit, let's go window, zoom. Let's just zoom out. You can see there's my other branch. So if you get only one branch, you may want to take a look at it again. Now notice this is going to come down and then work its way back up. This one's coming straight down like this. And so this is going to be a little trickier to draw. We do know that it crosses our axis here. And so let me go back here. We would want to put in some other points to get a good graph. But it's going to come down like this and then hit through here and come back up. And then our other branch is going to be up over here. This would be a lot better if we had better points or a bigger window. The domain for this then is negative infinity to negative 2, and then 2 or negative 2 to infinity. The range, we would have to find that minimum value, whatever this is right here. And so I'm going to zoom back in, menu, zoom in. We're going to zoom into this point right here, and I want to find the minimum value. So analyze graph, minimum, and there you have it. 0.5 and 1 is our minimum value, which 0.5 and 1 would be right there. So this is actually going to come down and then go back up. And so we're going to say that it goes from 1 to infinity as our range. So there's some examples. Some of them are a little bit trickier than others. If you got a little confused, watch again, and we'll talk a little bit about it tomorrow.